Hello friends, today we shall look at an extension of differential calculus known as implicit differentiation. Now, in differential calculus, whenever an equation for y is written in terms of x, such that y is equal to x squared plus 3x. Now, it is very easy to find the differential coefficients of this kind of function using the general method of differentiation. And that general method of differentiation is known as explicit differentiation. Explicit differentiation. However, for equations like x squared y plus x y squared is equal to 3x, we can see that it is difficult to rearrange the positions of x and y. Alright, so in this kind of function, the only way to find the differential coefficients is by using the implicit differentiation technique. And the rule of engagement here says differentiate x normally using the general method of differentiation, but whenever you differentiate y, multiply the result by dy dx. That is the rule of engagement. Alright, so let's look at a few examples to understand it better. Question 1 says if x raised to power 3 plus y raised to power 3 is equal to maybe 3xy, find dy dx. Okay, now what we are going to have here now, we differentiate x raised to power 3 and the result will be 3x squared plus, when we differentiate y raised to power 3, we are going to have 3y squared dy dx. Anytime you differentiate y, multiply the result by dy dx. And this is equal to, when we differentiate x here, the result is 3y. Plus, when we differentiate y here, the result will be 3x, then dy dx. Okay, now when we collect the like terms by transferring this one to the left hand side and this one to the right hand side, you have 3y squared dy dx minus 3x dy dx is equal to 3y, this one crossing over, minus 3x squared. Okay, now since the y dx is common here, you factor it out. So we're going to have 3y squared minus 3x dy dx is equal to 3y minus 3x squared. Okay, now to find the y dx, we're going to divide both sides by this parameter here. So dy dx is equal to 3y minus 3x squared divided by 3y squared minus 3x. So dy dx is equal to, now since 3 is common here, I factor it out. So we have 3. Then what remains here is y minus what remains here is x squared divided by, now you factor out 3 here too, 3 into what remains here is y squared minus what remains here is x. Now this 3 here, we cancel this 3. So finally, dy dx is equal to y minus x squared divided by y squared minus x. And that is the differential coefficient of this function here. Let's look at example number 2. So example 2 is this. If x squared y plus x y squared is equal to 13. Find dy dx. Okay, so what we are going to do here is to differentiate x. When we differentiate x here, the result will be 2xy plus, when we differentiate y here, then the result will be x squared, then multiplied by dy dx. Okay, plus, now when we differentiate x here, the result will be y squared plus, when we differentiate y here, the result will be 2x y, then multiplied by dy dx is equal to, the differential coefficient of 13 is equal to 0 because 13 is a constant. Now we now collect the like terms. So we have x squared dy dx plus 2xy dy dx is equal to, we now transfer this and this to the right hand side of the equation. Now we're going to have minus 2xy, then minus y squared. All right, so now since the y dx is common, we're going to factor it out. So we have x squared plus 2xy into dy dx is equal to minus 2xy minus y squared. Okay, now to find the y dx, we divide both sides by this. So dy dx is equal to minus 2xy minus y squared divided by x squared plus 2xy. Okay, now dy dx is equal to, now here it is very clear that y is common. Now since y is common, we are going to factor it out. So we have minus y into, what remains here now is 2x, then plus, what remains here is y, because minus y times 2x will give us minus 2xy, and that minus y times y will give us y squared. Now divided by, now x is common, you factor it out, x into, what remains here now is x plus, what remains here is 2y. And that is the differential coefficient of this function. Now let's look at example number 3. Now it says if x squared plus y squared plus 3y squared plus 5 is equal to 10, find dy dx. Okay, now, okay, so we're going to differentiate x. When we differentiate x here, the result is 2x. So we have 2x plus, when we differentiate y here, the result is 2y dy dx. Then plus, when we differentiate y here, the result will be 6y dy dx. And when we differentiate 5 here, the result is 0. So there's no need writing that 0 here. Now this is equal to, when we differentiate 10, the result is 0. Alright. Now we now factor out the common terms. By transferring this one to the right hand side, we are going to have 2y dy dx plus 6y dy dx is equal to, this one crossing over will give us minus 2x. Okay, now since dy dx is common, you will have 2y plus 6y dy dx is equal to minus 2x. Now 2y plus 6y will give us 8y. So we have 8y dy dx is equal to minus 2x. To find dy dx, you divide both sides by 8y. So dy dx is equal to minus 2x over 8y. Now we know that these two, we cancel this 8 to give us 4. So that means that dy dx is equal to minus x divided by 4y. And that is the differential coefficient of this function. Now, let's look at example number 4. Okay, now suppose we have if y is equal to x raised to power x, find dy dx. Okay, now we're going to see that in this kind of expression, the only way the differential coefficient of this expression can be obtained is by introducing natural logarithm on both sides of the equation. So we introduce natural logarithm here and here. So we're going to have ln y is equal to ln x raised to power x. Okay, now we'll have ln y is equal to, when a logarithm is raised to a certain power, the power is used to multiply the logarithm itself. So we have x ln x. Now we now differentiate. The derivative of ln y is 1 over y multiplied by dy dx is equal to, now here is a product, so we're going to use product rule to differentiate it. Now let's call this parameter x to be u, and this one, let's call it v. All right, so we use the normal method of differentiating products, that is a u dv dx plus v du dx. U is x, dv dx of ln x is a 1 over x, then plus v is ln x multiplied by du dx of x is 1. Okay, now 1 over y dy dx is equal to, this x here, we cancel this x, we're left with 1 here. Now plus ln x times 1 will give us ln x. So now we're going to multiply both sides by y in order to cancel this y here. So we're going to have y times 1 over y dy dx is equal to y multiplied by 1 plus ln x. Now this y here, we cancel this y. So we are now left with dy dx is equal to, now remember that y is x raised to power x, so we're going to replace it there. So we have x raised to power x into 1 plus ln x, and that is the differential coefficient of that function. Finally, question 5. If y is equal to x raised to power sine x find dy dx. Okay, now as usual, we are going to introduce the natural logarithm on both sides of the equation. So we are going to have len y is equal to len x raised to power sine x. All right. So now we have len y is equal to this sine x we move down to multiply. We have sine x len x. So when we now differentiate len y, we are going to have 1 over y multiplied by dy dx is equal to, when we differentiate this function, is a product function. So we call u to be sine x and len x to be v. Now, u dv dx plus v du dx, u is sine x multiplied by dv dx of len x is 1 over x. Now, plus v is len x multiplied by dv dx of the du dx of sine x is cos x. So here we're going to have 1 over y dy dx is equal to sine x times 1 will give us sine x divided by this x, then plus len x cos x. Okay, now here we're now going to multiply both sides by y in order to eliminate this y here. So we're going to have y times 1 over y dy dx is equal to y multiplied by sine x over x plus len x cos x. Okay, now this, we cancel this. We're now left with dy dx is equal to, remember that y is x raised to power sine x. So we have x raised to power sine x into sine x over x plus len x cos x. And that is the differential coefficient of this function. Thank you very much for your audience. Please don't forget to share our videos and subscribe to our YouTube channel.